For part D of this problem, we're asked for time between 0 and 6, at what time t is the amount of sand on the beach a minimum? And what is the minimum value? Justify your answers. Well, from the function that we have here for the derivative for y prime of t, let's step back. We have this function y of t, which is the total amount of sand on the beach. And because y of t is continuous on the closed interval from 0 to 6, the extreme value theorem will guarantees the existence of an absolute min. And furthermore, this must occur at either a critical point or an end point. So I know my endpoints are 0 to 6, 0 and 6, and so I'm going to start with a little table showing those endpoints. Now I also need to find the critical values, and those will be the places where the derivative y prime of t is equal to 0. Now I already have in the calculator y2 minus y1, which is my y prime of t. So I'm going to graph that to find the zeros. I'm going to turn off the other functions real quick. I'm going to go ahead and graph. I need to set up my window. My x values should go from 0 to 6. So I go 0 to 6, which I have by 1. My y values will go -5 to 5. You can try something else. And you can see from this that there's only one critical value on that interval, and it occurs somewhere between 5 and 6. We find that value by going second calc 0, left bound 0, right bound 6, enter for guess, and it gives it to me at 5.118. I'm going to save that value, quit out of there. I'm going to do x store alpha a, and I will go back then to my graph. So what I need to do now is to find the value of y at each of those points. Well, we're told that y of 0, the amount of sand on the beach at time t equals 0, is 2,500 cubic yards. Now I can find the integral of this y prime of t from 0 to 5.118, and that will give me the change in the amount of sand on the beach over that time interval. I still have to add that to the initial value. So let's just do that real quick. Second calc, option number 7, lower limit is 0, upper limit is a, and that gives me a value of -7.631 rounded to 3 decimal places. I hit plus, I add 2,500, and I get 2492.369. Now I can tell at this point, if I go back to my graph, you see how the derivative was always negative, which means I was decreasing, the amount of sand on the beach was decreasing the whole time up until 5.118. But after that it turns positive. So my lowest point has to be at 5.118 because I'm just going to add more sand after that point. But still, I'm going to go through and calculate this on the calculator, and I'm going to do an integral, option 7, from 0 all the way up to 6, and I get -6.723. I'm going to add that to 2,500, and I get 2493.277. And we can see that indeed the minimum amount of sand on the beach was at time t equals 5.118. Alright, I just should use a statement to conclude this, and so I simply state minimum amount of sand is 2492.369 yards cubed at t equals 5.118 hours. Okay, and that wraps up this problem.